Hey everyone, welcome back to another video, and in today's video we will be learning about memory management in Python. So what is actually memory? Memory is a place in computers where the actual data that we use is stored. It can be your SSD, it can be your hard disk, or it can be your RAM. In our example, when a program is being executed, all the data that is being used by that program is stored in our RAM. To have a better understanding of Python memory, we have a look at this architecture. This architecture has three layers. At the bottom layer, we have the hardware layer, which is the RAM. This is the actual place where all the objects or variables is being stored. On top of it sits the operating system, which is responsible for writing and erasing data from the RAM. And then we have our Python interpreter. This Python interpreter has a dedicated memory manager which has the job to tell the operating system how much memory or which objects does it needs to create. In this video, we will be learning about how memory is being managed by a particular Python implementation, which is CPython. Now, what is an implementation? Look, Python is a programming language that is written in a form of reference manual, which is not useful by itself. So, we need someone who translates or interprets that Python code into machine readable bytecode. Here comes the role of our Python implementation. What this Python implementation does, it takes your Python code and interprets it into a machine readable bytecode, which is then being run by a virtual machine on your computer. But this video was supposed to be on memory management in Python. And how is learning about C Python actually relevant? Look, C Python is written in programming language C, and uh, it has some algorithms and structures which help it manage the memory. So, C Python is written in programming language C, and C does not natively supports object oriented programming, because of which we have an interesting design. We all know that everything in Python is an object. Even data types like int or str like string are also objects. In C Python, we have got a struct named PyObject, and every other object in Python uses this PyObject. Now, what is a struct? Struct is simply a data type in data type in C programming language, but simply we can understand that it is like a class that has got attributes but no methods. This PyObject has got basically two attributes, one being obrefcnt and other being obtype. This obrefcnt holds the number of references that are being pointed to that object, and obtype holds the reference of the object of the data type. Like we know, like for example, a equals to 10. This a equals to 10 will have an object will have an object this this is object 10, and this object 10's and this object will have obrefcnt and ob type, and the ob type will point to the object of int. So, before we move into learning C Python specific structures, first we distinguish between two memory regions created during a execution of a program. Now, when a program is being run, there are two memory regions being created in a memory, one being the stack memory and other being the heap memory. This stack memory is actually the data structure stack, and Whenever a mm, uh, whenever an function is being called, a stack frame is being created inside this stack memory, and that particular stack frame stores or holds the variables and return address of that function that are local to that function. For example, if a function for example there is a function in which a variable is being declared a equals to 10, what happens? uh, and what happens in the memory? A variable is being created inside this stack frame, and another object is being created inside this heap memory. This heap memory has the object 10, and this variable simply points to this object 10. Whenever this function returns, this whole stack frame, including all the variables it holds, are being removed. But this object stays for some time in the memory. Now, now the heap memory. Heap memory is the memory region where all the actual objects are being stored. Now, for efficiency, C Python's memory manager divides this heap memory region into divides this heap memory region among two allocators. First one being the raw allocator, and the second one being the object allocator. Whenever a small object which needs a very small amount of space are created and managed by this object allocator, and large objects like a list of 10,000 elements are handled by this raw allocator. Why two allocators are needed? Look, whenever an object needs to be created, the Python memory manager sends a request to the operating system that this object needs to be created, allocate some space. And every time repeating this process would be very inefficient. That is the reason we have two allocators. For small objects like int, string, or small lists, dictionaries, the memory allocation is being done by the object allocator. And for large objects like a list of 10,000 elements or more is being done by the raw allocator. What this raw allocator does, it directly communicates with the operating system and allocates memory for the object. What this object allocator does is that it already preoccupies some fixed space into the RAM at the beginning of the execution of a program. The C Python's object allocator organizes this heap memory region into various chunks. Those chunks follow a three-level hierarchy. The biggest of them being the arena. Each arena is a is the largest chunk of memory created inside the heap. This arena has a fixed size which is 256 KB. This arena is then divided into various pools. Each pools each pool has a size of 4 KB, and each pool each pool is further divided into blocks of memories. Now, these blocks can be of size from 8 bytes to 512 bytes. and in one pool all the blocks are of same size. Like for example, all these blocks in this pool are of size 8 bytes, and this pool has all blocks of size 16 bytes, and this pool has all blocks of size 32 bytes. This goes on to 512 bytes, and all the size are of multiples of 8. For example, an object which needs a memory space of 41 bytes, then this object is being stored into a memory block of 48 bytes. And if there is a object object which requires 30 bytes of space, then it is being kept in a block of 32 bytes. So, let us sum up everything we learned in this video by understanding the flow that what happens actually behind the scene when a program is being run. Consider this code snippet. Here we have defined two functions f1 and f2, and uh, f2 is being called by the main function. Here, so what happens? The interpreter hits this f2 function. Now, this f2 function seems that it is outside any function, but actually this f2 function is inside the main function. So in the stack memory, a stack frame will be created for the main function. Main function. This main function is calling this f2 function. So another stack frame is being created here, and this stack frame is of f2. This f2 function is creating a variable arr, which, and inside this variable arr we have a list, and that list has a contraction that creates a list which has 1 lakh elements. So this type of objects are very large and occupies very big space. So to handle this list, so for creation of this object ARR, the task is being given to the raw allocator, which directly communicates with the operating system and creates an object in the memory. And this ARR variable is then being pointed to this object in the heap memory. Then it prints a simple hello. The hello gets logged onto your command line or your shell. Then the result then another object is being created named result, and that result stores the value that is being returned from the f1 function. So here we have the result variable, and this result variable holds what is being returned by the f1 function. So the f1 function is being called, another stack frame is being created, and this stack frame is for the f1 function. This f1 inside the f1 function, a variable is being declared which is x equal to 40, or a variable is being created in this f1 stack frame, and an object which is an int object. Now, int objects occupy 28 bytes. Int object occupies 28 bytes of 28 bytes of memory. So, so an object is being created inside a block that is, and the nearest multiple of 8 to 28 is 32. So object gets created inside the 32 bytes block in a pool of 32 bytes pool. And this x variable then points to this object 40. Now this this function f1 returns. When this function returns, this this stack frame is being deleted, and this result now holds the reference to this object 40. Then, okay, so we missed one thing here. There will the function will also return. Now, when this f2 function returns, this f2 stack frame is also being deleted. And finally, the main function ends, and this main function stack frame is also being deleted. But these data are still in the memory and occupy space. This these objects now have reference zeros. So references 0, and they don't have any use now. So we need to free the memory which these objects hold. Here comes the role of the garbage garbage collector. We already have talked about this garbage collector in our previous video, so you can watch it and understand about garbage collector there. So this was pretty much it for the video. You can check out some links that I have given in the description to some blogs and YouTube videos. Thank you.